yet has our resting zone in this case. Now this is not yet a true growth plate because we don't have that secondary bone site yet. Okay, this is still a very, very early bone. So you truly get an epiphysis when that secondary bone region is actually already formed. Okay, but in this case, this would be considered the resting zone over here. Now, what is this surface? Name the surface.
Epiphyseal plate?
The surface. What is the surface? What do you expect to see on the surface of bones at the articular surface? It's the articular surface. Okay. At your articular surface, funny enough, you do not get a periosteum. Right. The articular surface actually is, because it has to be glassy, so it's actually the exposed chondrocytes and cartilage. All right. No perichondrium at the articular surface itself. But the minute we start going off, if you look over here, and again, this is for consumption, this is not for the exam, but you can see here we've now got perichondrium over here, and you can see how that perichondrium thins out and pretty much disappears by the time we get up to the articular surface over here. All right?
So then what's at the articular surface? Is it cartilage?
So the articular surface is going to be cartilage. Right? Not going to be in an exam, trust me. But this could be on an exam. From the left of my pointer to the right of my pointer, name the zone. Zone of hypertrophy, hypertrophic zone, both of those are fine. From the left of the pointer to the right of the pointer, zone of calcified cartilage layer would be fine. Okay. And then underneath here, name this zone. Zone of ossification. All right. What kind of bone tissue do you find in the zone of ossification? Woven bone. The pointer is sitting on what kind of tissue? It is mineralized, but that's not really what I'm trying to get at. Calcified cartilage. Right? So here's the calcified cartilage, and here's our woven bone laid down on the side of that calcified cartilage. Right. The blue purple.
Is it calcium?
The blue purplish color here is not from the calcification. It's actually from taking all those proteoglycans and squishing them down really close. So you can see it looks almost like territorial matrix. Okay. So just because it's got all the water squeezed out of it. So yes or no question: is this woven bone?
Yes.
Yes. All right, from the bottom of my pointer to the top of my pointer, name this structure.
Periosteum.
Periosteum, okay. The pointer is spanning what layer? Fibrous, be specific. Fibrous layer of the periosteum, okay. And then therefore this is osteogenic layer of the periosteum. Name the layer at the top of this pointer. I heard it here. Endosteum. Okay. Name the cell at the top of this pointer. Bone lining cell. Okay. Name the cell at the top of this pointer. Osteoblast. These osteoblasts are laying down what kind of bone? Lamella bone. Why? All of them are in a row together, acting together. They're not individual. All right? Name the space at the top of the pointer. Lacuna. Name the cell in that space. Osteocyte. All right, this is going to be a little bit tricky, but when you look at these, that one, this one, and this one, name these cells. Osteoclasts. These cells would sit in what structure? Hauschips lacunae. If I pointed at a Hauschips lacunae and said name the space, is a Hauschips lacuna. Okay. If I put a circle around here and said name this structure, osteon, what's another correct name for it? Haversian system. My pointer is in what space? Haversian canal. These long little skinny black lines are representative of canaliculi. This pointer is in what space? Lacuna. What cell resides in this space? Do these canaliculi linked lacunae?
That's correct.
Yes.
Okay. What cell structure resides in these spaces? Filopodia. Right. Okay. Name these lamellae. Interstitial lamellae. Name these lamellae.
Concentric.
Right, concentric lamellae or circumferential. All right, concentric means one on top of the other. That is correct. They are circumferential because they're around the osteon, okay, or around the Haversian canal. Name this space.
Volkmann's canal.
Volkmann's canal. Okay.
Which one was interstitial? Which one was interstitial?
So the question is, which one of these are interstitial spaces? The interstitial spaces represent earlier Haversian systems that have been remodeled away. And what you'll see is you'll see just little bits and pieces of them left in between your new osteons. Okay? So those are the, yes. Show you it. This is the Volkmann's canal. So remember, all of these are Haversian canals because your Haversian canals all tend to run in the same direction. All right? And most of the canals that we're going to see are going to be Haversian canals. When we see canals going sideways, right, perpendicular to your Haversian canals, and they join two Haversian canals together, then that is a Volkmann's canal. I think that's a good example of one. Here's another one here. All right.
Can you go
There's
to the
part of one here.
Hauschips lacuna again? The Hauschips lacuna?
All right.
Was that a different slide? I'm sorry.
Yeah, no problem. So the question is, let's have a look at a Hauschips lacuna. Of course, that's going to take me forever to find one for you. All right, so unfortunately during the process, especially when we have these hard tissues, what happens is as we dehydrate them, the softer tissues will tend to pull away because